Hi there. Let's now discuss the solution for pre-processing of complaint analytics. For the first question, we need to discuss accuracy, completeness, and consistency issues between the missing timestamps, contradictory narratives, and mistyped sections. We need to propose two dimensionality relevant to legal analytics. So let's talk about this. The accuracy, does the data reflect reality, like mistyped IPC sections or incorrect spellings of names are the pitfalls of accuracy. Completeness is all the required data present, that is the missing timestamps, the witnesses, all these are present or not in the data set. So, for the consistency, there should not be any contradictive narratives that are in place in this. So, in order to handle this, we can ignore the tuples or delete the entire complaints that this is the only viable option for data set that are huge and missing data is minimal. So, otherwise, the valuable legal proceedings are lost. So the other method is manual completion. The legal expert reviews and fills the blanks. Highly accurate but very slow and expensive. There is a global constants. Fill it with unknown or -1. The algorithm might mistake this for a real pattern, causing misinterpretation. And another method is basically central tendency imputation. Basically fill the data with mean or median, skewed data, symmetric data to of the attribute, maintaining statistical distribution. Another one is class specific imputation. Use median values for complaint or in these same offense categories, such as median loss for theft cases and so on. Most probable values use regression or decision trees to predict the missing values based on the available features, leveraging the existing data relationship that are confirmed to be true. The next question asks us for the extraction of smoothing extracted features scores using the evidence strength list from A2. So number one is to smooth using bin means with bin depth 3. We need to suggest ways to detect outliers, rare, very high impact with low evidence. We need to discuss other smoothing methods such as bin medians, LOESS, moving averages, and robust estimators. So let's talk about the bin depth 3. First, we need to create 9 bins, and then we are going to incrementally add the values inside these bins and calculate the means for each of them. The original data is smoothed by replacing the each value with a bin and then with its calculated mean, which reduces the noise and generates highlighting the general trends. Next, for detecting the outliers, we can use a box plot the values over above the third quartile, that is the third quartile plus 1.5 into the IQR, that is the interquartile range, or below the Q1, that is the Q1 minus 1.5 into IQR, are flagged as potential outliers. In the Z score, data points with a Z score greater than 3 or less than -3 are considered outliers. And similarly, in legal DSS, high impact combined with low evidence is a specific outlier that can indicate a false or exaggerated complaint requiring deeper investigation before filing the complaint. Other smoothing methods are of that are suggested in here are bin medians we already saw. Apart from this, we have moving averages. Each value is replaced with the average of itself and its neighbors. Like 3 pointer moving averages creates a smoother series. LOESS, that is the locally estimated scatter plot smoothing, fills a smooth curve through data points using local regression, ideal for complex and non-linear patterns. Next, we have the challenges in integrating the DSS. So the main challenges are schema integration, combining the data from diverse sources like EFIR databases and physical station logs. The key challenge is to mapping different field names with the unified global schema. So time of incidence with occurrence time and so on and so forth. Handling redundancy is also a core challenge. Identifying duplicate entries with the same crime might be reported in multiple different ways across different systems. The solution is to create a correlation analysis can detect it if one attribute implies another one, reducing the redundant features using data parsimony. And for another challenge that we face is resolving the conflicts. When the merge pool presents conflicting information, one source states a loss of 50K, another states a loss of 5K. So the solution is to prioritize sources with higher prevalence and using voting and averaging mechanisms to ultimately determine the real outliers. Normalization methods for feature scaling are as follows. Min-max normalization linearly transforms the data to a fixed range, typically between 0 and 1. While it preserves the relationship, it is highly sensitive to outliers which can distort the scaling. The z-score normalization scales the database based on its mean and standard deviation. Values represent how many standard deviations there are from the mean, making it effective when min-max values are unknown or extreme. Z-score with MAD, that is the mean absolute deviation, similar to Z-score but uses MAD instead of a standard deviation. This method is more robust against outliers because the deviation are not square, reducing the disproportionate impact. Decimal scaling, on the other hand, moves the decimal point of values of attribute A. The number of decimal points moved depends on the maximum absolute value of A, simplifying the numerical interpretations without altering the relative differences. The next question is about binning case severity scores. That are scores are given as 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, and 215. We are partitioning them into equal frequency bins, equal width bins, and clustering based bins. So for the equal frequency bins, we are taking those which are the most occurrent and classifying those into three bins, which we get as bin 1 equal to 5, 10, 11, 13, 15, 35, 50, 55. And for bin 3, we get 72, 92, 204, and 215. For equal width, we select a range, that is the range is 210. And with a width of 70, we create three bins, 5 to 75, uh, because 5 is the minimum most value, 76 to 145, 145 to 216, and we place those values that satisfy this condition. This particular condition is demarcation to be inside this bin. Apart from this, clustering based algorithms utilize k-means to group numerically close values, naturally separating low severity cases from extreme outliers like 204 and 205. Apart from this, the last question is about feature scaling and selective mapping, section mapping. Summarize this using flowchart. So here we are. The feature selection is critical for building the efficient legal DSS. It identifies which complaint attributes features are most relevant for predicting the correct IPC section, reducing the noise and improving the model accuracy. There are three techniques for this: forward section, backward elimination, and a hybrid method that combines both approaches from optimal results. In forward selection, we start with no features, add the best ones iteratively, and in backward elimination, we start with all the features and remove the worst ones iteratively. So let's have a look. We start from the empty, begin with the empty feature set, no attributes is selected. This is the baseline state. Evaluate all the features for each available features individually. We calculate the accuracy performance metrics, F1 scores, and so on, while using only the single features to predict IPC sections. Step 3 is to add the best feature. Select the feature that provides the highest improvement in model performance, add it to features active feature set, and then we do iterative addition for each remaining feature, testing, adding to the correct data set, measure the incremental improvement in accuracy, and we continue this until convergence. The advantages are it is computationally efficient, it is interpretable, and avoids overfitting. However, it may miss feature interactions, and it is a greedy approach, so it might get stuck in local optimum. Apart from this, we have backward elimination, removing weak features first. So we start with all the features, begin with a complete set of all the available attributes. Then we evaluate the current model, train the DSS model using all the features, and measure the performance by all the performance metrics that we have, like accuracy, F1 score, and so on. Then we test feature removal, where we systematically remove each feature one at a time and measure the impact on the model performance, identify which feature removal causes the least performance degradation. Then we permanently remove the features with the weakest feature. This is typically the feature with the lowest statistical significance or correlation with the target IPC section. We repeat this process step 2 to 4 by continuing the removing features until removing any features would significantly harm the model performance, and then we have obtained the final feature set. Apart from this, the advantages are it considers feature interactions. It often finds better solutions than forward selection. It is computationally intensive, however, and may remove some important features early on. The hybrid method, that is the stepwise selection, initializes the best features, initialize with the best feature by selecting the single features that provide the highest individual performance, similar to forward selection step. First step in forward selection, add the best remaining features, iteratively add the uh, features that provide the most significant improvement to the current feature set. Evaluate these features after each addition. Evaluate whether the currently added selected feature has become redundant or less important due to interaction with newly added features. Remove redundant features if a previously selected feature now contributes minimally due to correlation between newer features. We need to remove that feature from our set. Then we repeat the step 2 to 4 until there is a convergence, and then we have the final optimal feature set. The advantages is that it balances both forward and backward approaches. It considers feature interactions, computationally more efficient than pure backward elimination. However, it is difficult to implement and requires careful threshold tuning. Thank you.